This is the first screencast for Chapter 14, Climate Alteration and Global Change. So this is an important chapter in terms of both the very dynamic situation that we are facing with climate change currently, the controversies that surround the science and policy, and the other important aspect to this chapter is that you'll see that many topics that we've previously touched on are tied together in this chapter. So keep in mind as you go through this the interconnectedness of Earth's systems, air, water, soil, and how environmental indicators allow us to measure and evaluate Earth's status. That's from way back in Chapter 1. But there are indicators such as temperature, food supply, etc. that allow us to measure and evaluate Earth's status and hopefully make changes. And that's the third part of this chapter. It ties together the concept of uniting science with policy and with economics to provide a sustainable environment for all going forward. Okay, so here we are looking at the situation with a case study of the polar bears. And polar bears and what's going on at the Arctic Circle are examples or an indicator of global warming. So polar bears have a very important role in this ecosystem, this frozen ecosystem. For example, the way they hunt for seals and manage that seal population is that there are typically, or historically, just tiny holes in the ice through which the seals pop up for air. They are mammals. And then the polar bears can hunt them. And once they've hunted them, the polar bears eat part of the carcass but leave the remainder of the carcass for other organisms such as Arctic foxes. So they are also providing not only a management tool for the number of seals, but also providing food for other organisms in the ecosystem. Unfortunately, temperatures in the Arctic have risen faster than they have elsewhere on Earth. And so as a result of that, there's less ice each year. And not only is there less on the surface, it's thinner. So this has resulted in a number of issues. The first one is that polar bears are no longer able to hunt seals at these little pop-up holes. They have to travel longer distances, which uses up more of their energy. And as a result, the polar bears have lost, on average, 150 pounds compared to what they used to weigh just 30 years ago. And so a male polar bear used to weigh between 800 and 1,400 pounds, but in the past 30 years, they're now down 150 pounds because of the energy expenditure and the less opportunity to feed. And in 2008, they were classified as threatened. Now, that's great that they were classified as threatened, which in layman's terms is endangered, but they're listed as threatened by the U.S., Russia, Canada, and Norway, and Greenland. But it doesn't help the polar bears really, because the problem of global warming is a global one. And so while it's good that the United States, Russia, Canada, Norway, and Greenland are recognizing and trying to protect the polar bears, they really can't be saved unless climate change is reversed. If it continues on this way, the polar bears simply won't survive. Okay, so let's look at some definitions. Oops, actually no. First we're going to look at objectives. So students will be able to distinguish among these terms: global change, global climate change, and global warming, and be able to give examples of each of those. So these terms are not interchangeable. If we start with global warming, that's the warming of air, water, and soil. If you move up a level to climate change, remember climate is not only temperature but also precipitation. So global climate change includes changes to climate, including changes not only to temperature but also precipitation globally. And then the more far-reaching or overreaching vocabulary term is global change. That can include any changes that don't have anything just to do with temperature and precipitation. So if we have changes in pH of the oceans, if we have rising oceans, if we have increased storm surge or increased hurricane intensity, these are all examples of global change. So we'll look at that more specifically. A second objective is that students will be able to explain how greenhouse gases have naturally warmed the Earth. Greenhouse gas does not mean a negative thing in and of itself. When it's natural, without it, well, we wouldn't have life as we know it on Earth. However, point number 3 here in the objectives, students will be able to explain how increased concentrations of greenhouse gases, which are released into the atmosphere from human activities, have caused changes to the natural warming process. So we'll look carefully at that data. Fourth, students will be able to discuss how people and the environment are affected by these global changes that we've talked about, which include climate change and global warming, but the overreaching effects on people and the environment are substantial. And last, students will be able to discuss 2 approaches to addressing global changes and what are some of the obstacles and what are some of the success stories that we've had in this. So now we're going to look at the terms global warming, climate change, and global change. And notice that I've had placed them in different fonts, with global warming being the smallest because it is part of climate change being the next level, which is part of global change. So many people, many students, and many families and household members have questions about all of these, starting with climate change. And often there's questions about what data is there and how, is there any conflicting data? Is the data reliable? How do we know these things? And so in order to understand global changes, we really need to look at what questions students have or their family members may have. So I'd like you to pause for a minute and think about what they are, and then I will put them, some of them that I've heard over the years, on the next slide. So first of all, some people want some further definition of exactly what changes we're talking about. And once we know what these changes are, once we've identified them, is this actually occurring? What is the evidence? And very particularly, how do we know what the temperature of the Earth was hundreds of thousands of years ago? We didn't have thermometers. Cavemen didn't carry them around and record the temperature of the Earth. So we need to look at various other indicators that tell us what the temperature of the Earth was, not even just hundreds of thousands of years ago, but what about millions of years ago? Are these changes natural or anthropogenic, meaning human-caused? So just like when we looked at extinction, there have been changes to the global atmosphere, land, air, soil, etc., in the past. And some, obviously, in the past, those were natural changes. But more specifically, the changes that we're seeing now are far greater than we've seen in the past, and we've been able to rule out certain natural changes that they're not happening now, which leaves us with anthropogenic, changes. And then there's the question of, so what? What are the consequences of climate change? Would it really be so bad if you're a New Englander to have a warm winter? Well, the consequences of climate change go beyond the level of human comfort and the amount of snow shoveling that you may need to do in the winter. There are some serious consequences, and so we will take a look at those. And last, is there anything we can do to mitigate the consequences? We're pretty far into global climate change, global change right now. And so to mitigate the consequences, we can look at everything from stopping the use of fossil fuels, to finding ways to sequester carbon dioxide so it doesn't get into the atmosphere, to just looking at other technologies and new ideas to mitigate the consequences before it's too late. Okay, now we're going to look a little more closely at the term global change. So I mentioned before that global warming, I'll skip down to here, is the overall warming of the earth, land, air, and ocean. And that climate change is the altered pattern of temperature and precipitation at the earth's surface. In addition to that, any changes to chemical, physical, or biological properties of the planet would be called global change. So chemical, physical, and biological properties. For example, you could have changes in not only the ocean water temperature, but the patterns of circulation. Think back to the chapter where we talked about how a molecule of water travels all around the globe in about 100 years. If we change these patterns of circulation, we will find that there are areas such as Europe that would be colder. They're in a more northern latitude, and yet it's the pattern of circulation which keeps them warmer, and so if we change that, they could have some severe consequences. There are changes to the pH of ocean water. Ocean water takes in atmosphere, it interacts with the atmosphere and takes in CO2, and that results in a higher pH, which affects organisms which have rely upon calcium carbonate to build their structures. So things like shells are affected. And then we have changes in storm intensity. That can affect certainly humans and wildlife. We have changes in the length of seasons. Some seasons are growing longer, and that can have positive or negative effects. And we certainly have changes to ice cover and depth, which I alluded to in the case study. Okay, I'm going to pause it here before we go on